to kick this off, one of the questions that we've been getting a lot at the booth from you guys at the Hiring Mixer and here, and even in general on social media is what is the difference between self-driving vehicles that you see on the road, that Uber's working on, that other companies are working on, and what we're doing? What is the difference between a self-driving vehicle and an autonomous robot?
Okay, I think I can start on this one. That's a great question. It's a different problem that we are trying to solve at Brain Corporation. When you have a self-driving vehicle, when you have an autonomous car, there's one safety aspect in it that is really important. Is when you have this car like driving at 65 miles an hour on the freeway, you cannot stop. No matter what decision you have to make a decision that has to be the best decision, but you cannot stop on the freeway. In the type of application we are looking for, if there is a safety concern, the machine can just stop and call for help. This is definitely an advantage on our side in implementing this technology. So if you believe, like we believe, that robots are going to be part of our environment very soon, not in 10, 15 years, but probably in 5 years, there will be a lot of robots around you that do some really useful tasks for you. We are taking advantage of this fact that you can always call for help and stop if there is any issue. That's the first difference. The second difference would be cars are made to go on the street. Cars navigate in an environment that is made for them. When you look at the robots that we retrofit to make them autonomous, they are actually evolving in environments that are made for people to move around. Grocery stores, malls, airports, those environments are made for humans to navigate, and we integrate our technology so that it can live around humans. That's another big difference. A third difference will probably be the technology that we use for self-driving vehicle in indoor environment and what you can use when you're doing self-driving cars. So when you're doing self-driving cars, you can take advantage of outdoor sensors like GPS, Global Positioning System, that we cannot use in our application. The main reason is we're operating most of our robots indoor, and when you're operating indoor, you don't have this type of technology. So that means all the sensors need to be on the robot. The robot needs to understand the world, needs to understand its environment without the use of any technology that lives outside of its body. And that makes the problem on our side a little bit more difficult, but that also makes the problem a little bit more interesting, because all the computation is embedded on the platform for the navigation. So if the GPS system goes down, and we all hope that's not going to happen, but our navigation solution will still work. And finally, the last difference that I see between self-driving vehicle and indoor navigation, or the type of robots that we do, is most of the time when you do outdoor navigation or self-driving car, you just want to go from point A to point B safely. When you do indoor navigation, where we retrofit the robot has a purpose in the environment. So when you look at this robot that EMA self-driving technology embedded in the floor scrubber move to actually scrub the floor, not to go to point A to point B. It would be a different application when you have like a security robot. This robot doesn't need to go from point A to point B. It needs to circle around a certain pattern in order to detect anomalies in the environment. Because of that, for example, when you are cleaning the floor, you need to go extremely close to obstacle. When you are doing self-driving technology, you try to stay as far as possible from everything. But if you will do that indoor, if you will do that for self-driving for cleaning equipment, then you will not do your job. So the accuracy of the navigation is actually very different from an outdoor navigation system to a self-driving technology that we are building.
And I think to comment, those are really great points, and I had a conversation with someone about this yesterday, but the social differences, not just on the technology differences, is when you think about a self-driving vehicle on the road, it is a tool, a transportation tool to get you from one place to another, whereas when you have an autonomous robot, especially for the first vertical that we're tackling, it's something that engages a group of people. It's in an industry, it's within a company with multiple employees that are interfacing with it. And it becomes something that changes that behavior and entity within a company itself. Whereas a lot of the self-driving vehicles, granted you can drive with your family in them or transport your family and your friends, it's a very within your nuclear radius of experiences interfacing technology. So speaking on the differences between those two, let's start diving into, you know, we all know there's a lot of cool robotics companies out there, and there's a lot of people doing cool things, there's a lot of software out there, but what makes us different from other robotics companies or other platforms like ROS?
That is a wonderful question. So I think, you know, the video may have showed our CEO kind of presenting our major difference is that we don't want to actually be building the hardware. We believe that the robots already exist today. They're operated by people. They just need brains. So that's kind of one differentiating factor, is that we're planning right away to be integrating with hundreds of different products. And right now there are no standards. So the platform that we're evolving has to be adaptable, has to be easily integrated with any number of different platforms. So there's differential drive robots, tricycle drive robots, balancing robots, possibly even bipedal or leg robots. So just the sheer variety of different platforms that we have to integrate with is going to be a great challenge for what we're doing. In particular, ROS, I always get questions about like, oh, are you guys taking advantage of ROS, or what are you doing with that? The funny part is that, you know, ROS came from Willow Garage, I would say probably in the early 2000s. And it's a wonderful platform for working on robotics projects. It's very, very popular in academia. People are constantly writing projects using ROS, but over the years, people have kind of found the platform to be deficient when it comes to actually releasing a product and sustaining that product through its entire life cycle. So for example, ROS doesn't offer anything with respect to reporting and analytics or device management or fleet management or any of the challenges that we face as we operate a fleet of hundreds or thousands of machines of varying types of products. So that's an area that we've really had to try to step in and fill in those gaps of the platform. I would say that's probably the biggest difference, is that as we move to bring our technology into the real markets with real people, there's just so much more than just the navigation technology that needs to be addressed. I think it's like all software, right? I mean, you have that 10% that's kind of core to your domain, the algorithms for navigation and perception and motion planning and all that kind of good stuff. But there's that other 90% of that dark software, right? All the boilerplate, moving data around, reporting, analytics, databases, security, and all that kind of good stuff. So I think that's probably where we differentiate ourselves the most.
Yeah, so,
Yes.
yeah, please.
Yeah, I think there are a couple of points also where we are different. So you mentioned, Cody, at the beginning of your response that we are using existing machines. So we are a software company, and we partner with OEMs that have machines that are currently manually operated by humans. And we take them and we make them autonomous. And by doing that, it's much easier for people to use our technology. I think this is a big differentiator from other platform company or robotics company that build the whole robot, and then when you present this system, this solution to your customer, they need to learn two things. They need to learn how to use this new robot and how to deploy this machine in the environment. And the approach that we take is fairly different. We say, okay, we're going to leverage from the knowledge of the people operating these machines. We're going to let them train the robots. So we use the terminology that is used is learning by demonstration. You may have heard of this term in the machine learning literature. But basically, we let the user drive the machine the same way that they were using their manual machine before, and only in one shot, the machine learns everything that it needs to know about the environment, about the task that needs to be done. And next day, you just have to push a button and the machine will do that automatically. And by partnering with OEMs and by retrofitting manual machine, we make sure that we can penetrate the market very easily, because the ease of use of our system is very different from the other robotic companies.
So I think that's a huge point to tackle on, is the real human factor in this. A lot of times in the common public media, the concept of robotics and AI, it's still very sci-fi-ish. People think about humanoid figures and they think about things that are still further. But when we partnered with OEM machines and we were talking to the people that would be using the machines, these manual machines have legacy behind them already. People have existing infrastructure from safety standpoints, regulation standpoints, even onboarding standpoints where they know how to use the machines. So our first vertical is floor care. And we are partnering with multiple OEMs to automate their machines, but let's kind of step back and get a little creative, because I mean, this is Developer Week after all. What other environments and what other industries do you, and each of you, let's start with you, Mark, where do you think another environment would benefit from our technology? Like I look at material handling or healthcare, but just your input on that.
Well, obviously, the most common one that comes to mind would be parts delivery on a factory floor. Obviously, there are a lot of robots out there that are attempting to do this. Some of them are doing it well, some of them not so much. The great thing about employing our technology on that is that you can turn our machines loose on a factory floor, and you're not going to be concerned about them rolling over your workers or running into your workers. This is not a Roomba. We don't bounce off walls. If we bounce off anything, we're in trouble.
So, you know, I'd love to say we can just sit up here and talk about like how great we are and how amazing we are. But each of us in each part of this technology faces huge challenges. From the user side, it's teaching someone who maybe doesn't interface with technology every day in their life to now being responsible for a robot that they have to integrate in their workflow. I'd love to know from the software, the mapping algorithm, even from the hardware aspects, like what are the challenges you see day to day or even future impacts with our technology?
Well, I'll cover it from the hardware aspect because, you know, hardware engineers should be seen and not heard most times.
Wait, so before you even go forward, I do want to touch on that because every time we have a conversation about robotics and AI, everyone wants to talk about machine learning and the software and, you know, talking about that, but there's a huge hardware aspect to support the AI stack, the vision-based navigation system. So,
well, one of the problems that we had to fight with early is how many microprocessors is it going to take in this machine? So far, we've got it down to 3. But whenever you start processing vision, your requirements for hardware tenfold increase. And we do a lot of vision processing, and we plan on doing more in the future. So if you're planning a robot, you have to take that into account firsthand. Are you going to have the microprocessor strength and the power to support your application?
So I'll talk a little bit about the software and the full navigation stack that we have. And I think one of the challenges that we have in software is when you do robots and when you have a piece of software that runs on the embedded platform, it's not a simple solution. It's like many different technology that we use. So a lot of people today are talking about deep learning and navigation intelligence and this type of things, but it's only a small piece of the technology that we build. You need to have like a really safe platform that moves in the environment. And how do you test safety if you are using deep learning techniques that's basically a black box where you give input to the system, it gives you some output. You don't really know how the machine works because this is so complex. There are like millions of connections with like some different weights, and you just know that it does the task, but you don't know how it does it. So when you want to create a safe robotic platform, you cannot only use deep learning. You definitely want to take advantage of this technology. You might want to have higher cognitive function for the system, being able to detect the mood of people or being able to detect specific object on the floor that might be very difficult to detect with other technology. Definitely you want to take advantage of that. But it's a full package, and how do you test this full navigation solution? How do you integrate it in the environment? It's one complication that we have, and I think something that you will probably touch base afterwards is how do you make this solution so simple that everybody can use it? How can you reduce the number of features in your system so that it's as easy as teaching and replay? You don't want like people to be robotic experts to deploy your machine, and if they need this level of expertise, robots are not going to be part of our environment tomorrow because you will need thousands of people retrofitting the environment and installing those robots in the world. So I think this is another complication but this is your domain of expertise there. How can we make that so simple so that people want to integrate this machine in the environment?
To touch on that a bit, it always comes down to time. With time, they say you can onboard anybody to do almost anything, but given our state, time is always the biggest constraint. So when I was working with the product team and the engineering team and looking, okay, what are the technical constraints to begin with, and then talking to the people that would be using the machines, the first thing that was very apparent was to maintain the workflow that they currently have. And I'm not going to have this talk without addressing, that there is an apprehension to technology. It isn't just to robotics and AI and thinking people are building Skynet, but even looking at data, think about how many iOS users do not want to update their phone because they might run out of space. Or, even myself with new Android updates, worrying about how the memory is going to behave. So there's always a little bit of apprehension to change. But when you onboard somebody and there's, again, legacy behavior, this machine looks almost the same as every other machine you've used. The behavior mechanisms are almost the same. The hardware is very, very similar, and there's a lot of familiarity. The adoption rate becomes a lot higher. And exploring it as a tool and not as something that is equal to you or doing what you do in your job. Cody, your challenges?
So, I think one of our really unique challenges, kind of going back to the idea of us integrating with existing platforms with no standards. So the dumb thing to do would be to copy and paste our code base for every single product that we do. But clearly that's going to have a combinatorial explosion in terms of the complexity of test. So how do we test our software for dozens of different platforms? They have different footprints, different mechanisms of drive. Their sensors are in slightly different locations. To JB's point earlier, we're placing these robots into complex environments that are shaped by our own complexity, right? We take for granted how complex our brains are, and even getting up onto the stage, right? How do you, like a robot getting up here is a very big technical challenge, and we take for granted that I just have legs and I can just stand up on the stage. So that complexity leaks into all of our environments, and as you walk around, you'll see little ledges and lifts and stairs and railings and handholds and all sorts of weird features in our environment. And every environment is different. An airport is different from a grocery store, which is different from a big box retailer, which is different from a hospital, which is different from a warehouse. And so every single product times every possible environment it could go into, there's very quickly an explosion of complexity. And so managing that complexity and trying to dial that complexity down so that we have a manageable product and we have a safe product is extremely challenging. It's probably, from my perspective, one of our biggest challenges as we're kind of scaling up and introducing all these new products.
What are the hardware and technical considerations, constraints, and processes that you have to go through when we start with a new OEM to put BrainOS and automate this robot?
I just won $5 doing that. It's important to note, and I mentioned before that our current systems have 3 processors, and BrainOS encompasses all 3 processors. So BrainOS isn't just running on one processor, it's running across 3 dissimilar processors, each tasked with its own job. JB had mentioned safety. We have a processor that's our safety processor. It's looking at all the sensors, comparing the data, looking for something in its way, and it can shut down the machine at any time. One processor just involved just for safety. So safety is a big deal where we come from. As I mentioned, we're not a Roomba. If we bump into anything, we're done. You're talking about a 600-pound machine minus the water. So we are not going to bump into anybody or anything. So it's very important from a hardware standpoint that you design your hardware such that one processor is involved with safety, a higher level processor does the navigation, has the AI, but the other processor may be involved with managing the communications between all of them.
So talking about safety and reliability, I mean, anytime a new technology emerges, those are the two pillars of support that cannot be compromised on. Understanding that and knowing that autonomous navigation and the conversation about autonomous navigation has been going on for a long time through various applications, military being one of those, what do each of you think the future holds for autonomous navigation? Stepping away from cars, and let's not talk about planes either.
Well, if you're going to have an intelligent robot, it's going to need to be able to navigate its environment. That's just a given. Robots aren't going to stand still and do nothing. They have to be able to move about, move around. They have to be able to interact. They have to be able to move items for us. That's what they're here for, to serve us. They have to be able to serve us. So autonomous navigation is very important in a robot.
For me personally as a designer, when I look at our technology, and you always want to solve a problem, and assisting and making our lives easier is a big part of that, but we were talking about industries that we'd love to see our technology utilized, and for me one of those would be increasing accessibility for people. When I was doing research with the team, a lot of times it came up that even though it's mandatory that we have ramps to help disabled people, that parking is done in a certain way, oftentimes that path of navigation, it's a bare minimum but not really as accessible as it should be. Same thing for public transportation or partaking in recreational activities like enjoying a park or being able to access, national parks and different features that a lot of us take for granted when we live in a city. So we talked about safety, we talked about reliability. Let's talk about security, because we are at Developer Week. So there's the data that belongs to our customers, and then there's our own IP, and then there's everything from the cloud data to data that's being transferred to data that we're recording and collecting. How do we deal with it all?
Yeah, so let's roll back real quick to the safety aspect. So when you're driving a 600 or 1,200 pound robot around, security is safety, obviously. Like, you cannot separate those two things. If we do not have a secure system, we do not have a safe system. The other thing that's really interesting is that the robot is collecting a lot of information about the world. It's got cameras, it's got depth sensors, it's got inertial sensors, it's building maps of floor spaces and that. So we have a tremendous amount of data that we're going to be collecting and processing. So of course there's going to be privacy concerns. So we need to keep that data all locked up. So there's all the network security and everything else. But for me, so I came from a background working in the data center and securing computers in the data center and HSMs and all that kind of fun stuff. But the most difficult thing about a robot is that unlike a data center, we actually just give it to our customer. There's no physical security, right? You have to hand the product to the customer with everything inside of it. So how do you actually secure that device to prevent it from being tampered with, to make sure that it maintains safety? As much as we all have a hacker spirit, I really don't want somebody who may not know the ins and outs of the system to be modifying our robot, maybe making the maximum speed faster or something like that. That's a really bad idea, specifically because we're operating in the public, around people, around families and children. So we take safety very seriously, and security is definitely a part of safety for what we're doing.
Jimmy, did you want to add to that or anything? Something that we don't often get to talk about, and it's a really cool feature of our robot, is the way that it does mapping. We have sensors, we have cameras on there, and the map that comes out of it is really exciting to customers because they see the features and the topographical characteristics of their store location and whatnot. Going back to the concept side, what do you guys see could be useful for that mapping data? And I can't take credit for this question. Some of you guys asked this at the booth yesterday, which is like, what else can you do with the map? I mean, it looks cool. I saw where the robot went, but...
Well, so I think it's going to depend on your application. Think about our current application. So we have the map. People want to see reports. People want to know how their store is cleaned, how their environment is clean. And this is something only by itself. So if you just think about it, like just a manual machine that is driven by someone, but then you can tell your customer at the end, okay, this is how you clean your environment. This is how you could optimize this process. This is how you could make it better, faster, and more clean over time. So this is one particular application, one particular use for maps. Then if you still think about the commercial space, for example, people do some shelf analytics. They might want to embed our technology with mapping of their store. They might want to see, okay, I'm missing this product at this specific location, and I can tell you that the price for this item at this other location is not right. So, and they can give you like a very specific location where it is in your environment that will help you to fix the issue. Or you could think about application where you want to drive the customer from the front of the store to an item on the back of the store, and the machine will know everything. And you can point on the screen the item that you wanna grab in the store, and then either the machine can show you the map of the environment, tell you how to go there, or it can drive you there and help you finding the product. So it's just like, I think there is an endless use of the maps that you can use. It's only your imagination there that is going to define what you want to do with this data.
So right now we're strictly B2B, but we are at Developer Week again, and something that a lot of the developers have been asking is, we are BrainOS, we keep talking about a platform, are we ever going to open it up to allow developers to build applications on it?
I would personally love to do that. I mean, why would we not? So right now, everybody that's going through university and studying robotics is going to be using ROS as a platform. So that's kind of like the gift from Willow Garage of 15 years ago, and it's been great to get people involved with robotics and to help things out. I would love to see BrainOS take a similar role. Selfishly, right? It's great to hire people that already know our stack. So there's obviously an incentive there to kind of open source that. There's the network effects of having people, hobbyists, students working with the platform, trying new things out, pushing its limits beyond what any one of us could imagine the platform doing. But in the short term, I think we have a lot of challenges related to integration and bringing in a new platform. So I think we're going to maintain a little bit more control over the platform in the short term as we evolve it, stabilize it, and really figure out how we're going to do what we're doing. But I think that's the direction we're going to want to go.
And I would like to open it up in about 5 minutes, so just to let you know, we are going to open it up for open questions. Another question that we got a lot from Hiring Week, the Hiring Mixer, was, I'm really into robotics. The whole concept of AI is very exciting to me. I'm a traditional software developer and do desktop applications or anything. How do I get started? How do I jump into the industry? And I can kind of see this a bit where the field of robotics tends to appear to be a very closed off sector.
Does anybody else want to take this?
Yeah, you take it.
I'll take this one. So this is something I see quite a bit of. I see a lot of people that are currently working on back-end services or front-end services, and they're obviously really interested in machine learning and AI and robotics, and they want to get involved. Of course, there's so many good resources out there. I know Udacity has a great robotics course where that kind of covers a lot more of the probabilistic robotics, some of your classical algorithms related to planning and localization, all that kind of good stuff. And then Udacity and Coursera have a lot of good courses on machine learning and deep learning. But those are available to a lot of different people, so that alone is not going to help you really stand out. I think really the ultimate thing is to actually have projects. So go out there and take and build a little robot. There's a lot of kits where you can take get a wheeled base and put a Raspberry Pi on there, put a camera on there. Try to make a robot that actually does something fun or useful, can fetch a beer for you from the fridge, or you can mount an iPad to it and have a little teleoperation robot. There's so many different fun projects you can do, and I think that experience is really, really important if you're looking to get into the industry.
Oh, Jimmy, Mark.
Yeah, no, I think that's a great resource of information. So there are like many resources available online. Udacity has really good classes. I would say that if you don't know anything about robotics, if you want to move in this segment, take this nanoclasses that they have, they are great. Do a project, do something fun with a robot shows that you can finish a project. You know, just like sometimes people talk to us and they're just like, oh yeah, we're really interested about that, but they're a little bit stuck with just an idea or an ideal of what they want to do. If you demonstrate that you actually build something from scratch, it's what is impressive for me, because most of the time it's not the final product or the final project that is going to be the purpose of it. Is everything that you're going to learn during this project. It's all the details, like the devil is in the detail, but it's very true. It's just like there are many things that you're going to realize. How an IMU works, and just like what is the deficiency, why should you compensate for bias and stuff like that. It's just every time you think about a solution, even the simplest thing ever, you will realize that it's way more complex to make something reliable and robust in our environment, and the amount of learning that you will get by doing this small project is going to be incredible, and it's going to help you advance in your career if you want to move into robotics.
And a note on that before I open it up to all of your questions. When I spoke with a lot of designers, front-end developers, and people that wanted to get into the design and the human factors aspect of robotics, I said the same thing that I would say to a mobile designer, which is when you're factoring the hardware performances, know the platform in which you're designing for and who the human is that interfaces with it. There's a real bigger platform and all of a sudden all the traditional things you learned growing up in the environments, from pushing buttons to opening doorknobs to traditional hardware constraints that I never considered before when I went from mobile and software into robotics, and just being aware and opening up your world to like a lot of those things that have been around